So we're going to have a look at the shapes of these molecules. We're going to use in the VSEPR, valence shell electron pair repulsion theory, in order to work this out. What you're going to need is your periodic table and your diagrams of the shapes of the molecules that are in your notes. And remember, we've got the parent shapes and then we've got the derivative shapes from those. So we're going to start with H2S. I'm going to go through each one in turn and build them up. So H2S, so sulfur is in group 6. So sulfur is in group 6, so that's got 6 electrons. Hydrogen can form 1 bond each, and there are 2 of them, so that's going to be 2 electrons. And if I put all of that together, that is 8 electrons. Need to divide that by 2, which gives me 4 pairs. I now have a look at my formula here, and there are 2 bonding pairs out of those 4 pairs, which basically means my 4 pairs are made up of 2 bonding pairs and 2 lone pairs. The 4 in total means that the parent shape is going to be tetrahedral, which is going to look like that. Put my sulfur in the middle, put 2 of my hydrogens on, and then convert the other 2 bonds into lone pairs here, and hopefully you can see that that is V-shaped, bent or non-linear. So I'm just going to draw that here now. So sulfur, hydrogen, hydrogen, lone pair here, lone pair there. And it has a bond angle of 104.5. That's 109.5. Take away 2.5, take away 2.5 for each of those lone pairs. Okay, CF4. So CF4, same as before. So carbon is in group 4, so it's got 4 electrons. Fluorine forms 1 covalent bond per fluorine, and there are 4 of them. So that gives me a total of 8 electrons. Divided by 2, which gives me 4 pairs. I now need to have a look at the formula, and I've got 4 that are going on there. So these 4 pairs are 4 bonding pairs of electrons, and there are no lone pairs. So that means that is going to be tetrahedral in shape. The fluorines on, and a bond angle of 109.5. So let's pop that on here. So carbon in the middle, fluorine, fluorine, and fluorine with a bond angle of 109.5. Okay, beryllium BF2. So BeF2, so beryllium is in group 2, so it has 2 electrons in its outer shell. Fluorine forms 1 covalent bond each, and there are 2 of them, so that's going to be 2 electrons. That's a total of 4. Divided by 2, that gives me 2 pairs. Check the formula. There's 2 there, which means I'm only going to have 2 pairs around that, so it's going to look like that, which is linear with a bond angle of 180 degrees. So we draw that in here. So fluorine, beryllium, fluorine, 180 degrees. Okay, next one, GeCl2. So GeCl2, so germanium is in group 4, which means it has 4 electrons in its outer shell. Chlorine can form 1 covalent bond here, and there are 2 of them. Put that together, that's going to be times 2, so that's going to be 6 electrons. Divided by 2, that's going to be 3 pairs. Check the formula. And you can see that 2 of those pairs are going to be bonding pairs. So I've got 2 bonding pairs and 1 lone pair. So the total of 3 here means it's going to be trigonal planar, which is going to look like that. Put my germanium in the middle, chlorine, chlorine, and convert one of my bonds there to a lone pair. Trigonal planar means the bond angle here is going to be 120 degrees, but because of the lone pair, that's going to be minus 2.5, which is 117.5. So draw that in here. And 17.5 degrees. Okay, next one. Aluminium bromide. So aluminium is in group 3, which means it has 3 electrons. Bromine can form 1 covalent bond, and there are 3 of them. So that's going to be 3. That's a total of 6 electrons. Divided by 2, that's 3 pairs. Check the formula. Well, there's only 3 things on here, which means 3 pairs are going to be 3 bonding pairs, no lone pairs. 3 means it's going to be trigonal planar with a bond angle of 120 degrees. So aluminium in the middle, bromine, 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 120 degrees. Okay, next one, OCl2. So OCl2, so oxygen is the central atom and it's in group 6. It has 6 electrons in its outer shell. Chlorine forms 1 covalent bond, and there are 2 of them that we need to get on, so that's going to be 2 electrons. That is a total of 8. Divided by 2, that gives me 4 pairs of electrons. Check the formula. There's 2 chlorines on there, which means there are 2 bonding pairs, 2 lone pairs. Total of 4 means it's going to be based upon tetrahedral. So start with that. Put my chlorines on 2 of them and change my other ones to lone pairs. And you can see there that that is non-linear, V-shaped or bent, okay? So pop that in here, oxygen with chlorine there, chlorine here, and pairs here and here. The bond angle there is 109.5, take away 2 lots of 2.5, which is 104.5 degrees. So hopefully that's okay. On to the next page. So silane, so SiH4. So again, just going to work each of these out until we kind of get the hang of it. So silicon is in group 4, has 4 electrons in its outer shell. Hydrogen can form 1 covalent bond each, and there's 4 of them going on there because it's SiH4. That gives me 8. Divided by 2, that's 4 pairs. And if I check my formula, there's 4 things going on, which basically means I've got 4 bonding pairs, no lone pairs. So that's going to be tetrahedral around silicon, so I'll draw that straight in. So there's silicon, hydrogen, hydrogen, and hydrogen with a bond angle of 109.5. Now, when you're explaining these, you have to talk about the pairs of electrons that are repelling. So there are 4 bonding pairs of electrons. There are no lone pairs of electrons. The 4 bonding pairs repel equally as far as possible the central atom. Okay, so 1 mark for this part here and 1 mark for that part there, which brings us on to the next one. So NF3. So draw the shape of an NF3 molecule. So NF3, so start with nitrogen, that's in group 5, so it's got 5 electrons in its outer shell. Fluorine can form 1 bond, and there are 3 of them. So that's going to be 3, that gives me a total of 8 electrons there. Divided by 2, which gives me 4 pairs. And if we look at the formula, 3 of those pairs are going to be bonding pairs, which means 1 of them will be a lone pair. So 3 bonding pairs, 1 lone pair. So the 4 pairs means that it's going to be based upon tetrahedral. So there's my tetrahedral shape. Put my 3 fluorines on here, and then convert 1 of them to a lone pair, which gives me trigonal pyramidal with a bond angle of 109.5, take away 2.5, which is 107. So let's pop that on here. So nitrogen, lone pair, fluorine, 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 bond angle of 107 degrees, and then explain why it is the shape that we've got. So we start with all the pairs of electrons. So we've got 3 bonding pairs of electrons, 1 lone pair of electrons. Okay, so that will be one of the marks. These repel around the central atom. Notice I've dropped the word equally because it's not equal now, because lone pairs repel more than the bonding pairs. And that bit there would give you the second mark. Okay, so some more difficult dot and cross diagrams coming up then now. So these have got a negative charge, so we're doing exactly the same, but we've got to take into account the negative charge. Okay, so here's how we're going to work it out. So let's jot this down. So SbF6. Now I think this is supposed to be a 2 minus rather than a 1 minus, but we'll have a look when we start to work it out. So Sb, so that's antimony, is in group 5, so that's got 5 electrons in its outer shell. I've got fluorine, which will form 1 electron, form 1 bond, so that's 1 electron times 6. So that's going to be 6 electrons. So no, that was a 1 minus. And then the charge on here, so let's add them at first. So 5 and 6 that's 11 electrons. The charge is a 1 minus, which means I need to add 1 electron to that, which means I have 12 electrons. Okay, so this is the extra step here. Divide by 2, that gives me 6 pairs. Need to check my formula. Got 6 things on there, which means they're all going to be bonding pairs. So 6 bonding pairs, no lone pairs. So our parent shape then is going to be octahedral, and I'll draw that straight into here. So Sb, F, 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 and it has a 1 minus charge. The bond angle on everything in here is going to be 90 degrees. Okay, next one, ICl2 plus. So ICl2 plus. So iodine is the central atom, because there's only one of them, but there's two chlorines. So iodine is in group 7, so it has 7 electrons. Chlorine forms 1 covalent bond each, so there's one of those, and we have 2 of them. So add those together, that's 7, 8, 9 electrons, okay? So I've got a 1 plus charge, which means I need to take 1 electron away, which gives me 8 electrons. So again, this is the extra step here. Divided by 2, that gives me 4 pairs. Have a look at how many I've got in my molecule. Well, I've got 2 there, which means that out of my 4 pairs, I'm going to have 2 bonding pairs and 2 lone pairs. The 4 means I've got tetrahedral as my parent shape. Okay, so I put my chlorine here, chlorine there. The 2 lone pairs, so convert those to lone pairs. There we go. And you can see that it's non-linear or V-shaped. The bond angle is 109.5 minus 2.5 minus another 2.5. So let's draw that in. Okay, so bond angle here, 104.5 degrees. Okay, next one is indium bromide with a 2 minus charge. So INBr5 with a 2 minus charge. So indium is in group 3, so that's 3 electrons. Bromine forms 1 covalent bond, so that's 1, but there's 5 of them, so that's going to be 5 electrons. That gives me 8 electrons there. I've got 2 minus charge, which means I need to add 2 electrons, which gives me 10 electrons. Divided by 2, that gives me 5 pairs. And if you look at the formula, I've got 5 things on here, which means I'm going to have 5 bonding pairs and no lone pairs of electrons. So 5 bonding pairs is going to give you that trigonal bipyramidal shape, if you look that up. So indium, so 1 above, 1 below, to the side, and then I've got a wedge. Bromine there, of course that's a 2 minus charge. Bond angle in this one, so there's 2 bond angles here, there's 90 degrees there and 120 degrees at that point there. Okay, next one, tin bromide. So SnBr3 minus. So tin is in group 4, so that's 4 electrons. Bromine does 1 covalent bond, so that's a 1 electron. There are 3 of them, which means in total I've got 7 electrons. It's a 1 minus charge, so I need to add 1 electron. So that makes 8 electrons. Divided by 2, that gives me 4 pairs. And I've got 3 bromines on here, which means 3 of my 4 pairs are bonding pairs. So 3 bonding pairs, 1 lone pair. 4 pairs here tells me it's based upon tetrahedral, that's the parent shape. So Sn, which gives me that, put 3 of my bromines on. Convert one of those to a lone pair, and you can see that's trigonal pyramidal with a bond angle of 109.5 minus 2.5, which gives 107. So let's pop that one in. So Sn, Br, lone pair there, and it has a 1 minus charge there. So the next one, ClF4 minus. Clf4 minus. So chlorine is a central atom. There's only one of them. It has 7 electrons in its outer shell. Fluorine forms 1 covalent bond each, and there are 4 of them. So that gives me 11 electrons. It has a 1 minus charge, so I need to add another electron on there, which gives me 12 electrons divided by 2, which is 6 pairs. Out of those 6 pairs, 4 of them are bonding pairs of electrons, which means 2 of them are lone pairs. So that's 4 bonding pairs, 2 lone pairs of electrons. So the total of 6 means the parent shape is going to be octahedral, so I'll start with that. So 4 fluorines on, I'm going to put them in the same plane here, and the reason for that is because with the lone pairs, they're going to want to be really as far away from each other as possible. So one underneath and one above. So because it's based on octahedral, the bond angle here is going to be 90 degrees. The lone pairs aren't going to have any effect here because as one of them pushes upwards, the other one is pushing downwards in the opposite direction by an equal amount, so the bond angle doesn't change. So draw that in here. So there's chlorine, fluorine, fluorine, and a bond angle of 90 degrees in there. Okay, next one. Beryllium fluoride with a 2 minus charge. So beryllium fluoride with a 2 minus charge. So beryllium is in group 2, so that's 2 electrons. Fluorine forms 1 covalent bond each, so that's 1 electron. There's 4 of them on there, so that's 4 electrons. That's a total of 6. 2 minus charge means I need to add on a further 2 electrons. That's 8. Divided by 2, that's 4 pairs. I only have 4 pairs, so they're going to be 4 bonding pairs, which means it's going to be tetrahedral. So I'll just draw that one straight in. So beryllium, fluorine, fluorine, fluorine here, 2 minus charge, and we'll have a bond angle of 0.5 degrees. Okay. So the really difficult ones are these ones on the last page. Okay, so I've got BiI4. So BiI4 with a minus charge. So bismuth is in group 5, so there's 5 electrons there. Iodine forms 1 covalent bond each, and I have 4 of them. So it's going to be 4 electrons. That's a total of 9 electrons. The 1 minus charge means I need to add another 1 electron, which gives me 10 electrons. Divided by 2, that gives me 5 pairs. From those 5 pairs, 4 of them are bonding pairs, which means 1 of them is a lone pair. So I've got 4 bonding pairs, 1 lone pair. So the 5 pairs means the parent shape is going to be trigonal bipyramidal, so I'll start with that. So there's bismuth, there's the 5. I need to remove 1. It doesn't really matter where you move 1, but it does give you a slightly different shape. If you remove this one here, it gives you the seesaw shape. However, the one that's probably easier to draw and name is if you remove that one there, put the lone pairs down here, and that gives you a trigonal pyramidal arrangement there. Okay, so let's draw all of that in. So bismuth with iodine, lone pair down here. The bond angle here is, well, it's going to be slightly smaller than 90 degrees. So if we apply the rule, it's going to be about 87.5 degrees there. Okay, so let's move on to IF5. So IF5, so iodine is in group 7, so it's got 7 electrons in its outer shell. Fluorine forms one covalent bond, and there are 5 of them. So 5 and 7 is 12, so we've got 12 electrons there. There's no charge, so I just need to divide it by 2. That gives me 6 pairs. So out of the 6 pairs, 5 of them are bonding pairs, which gives me 1 lone pair. So the fact I've got 6 means that the parent shape is going to be octahedral. Which is going to look like that. And again, it doesn't really matter which one I remove, as long as it kind of looks okay. I'd remove the bottom one, which gives me this here. Put my fluorines on in the other positions. I'll just draw those straight into here now. So iodine, fluorine, lone pair at the bottom there. And again, the bond angles here are still going to be 90 degrees. Here they're probably going to be slightly less. So there'd be a range in the Mart scheme, so I'm just going to say 90 degrees, but you could have 87.5 in the top one, I guess. And then I3 minus. So I3 minus. The way to think about I3 minus, because there's only one element here, is that one of the 3 is the central atom, the other 2 therefore are around it. So the way to think of it is kind of like I2 minus, okay? So if I kind of base it on that, iodine as a central atom has 7 electrons in its outer shell. The other iodines, the other 2 iodines form 1 covalent bond each, and there's 2 of them. So that's 2 electrons there, so that's 7, 8, 9 electrons. There's a 1 minus charge, so I need to add another electron here, which gives me 10 electrons. Divided by 2, that's 5 pairs, but out of my 5 pairs, 2 of them are being used as a bond, okay? Which means the other 3 are lone pairs. So I've got 2 bonding pairs, 3 lone pairs. So 5 pairs is going to give me the trigonal planar arrangement, so I'll start with that. Which is going to look like this. To have the 3 pairs of electrons, the 3 lone pairs of electrons and the 2 bonding pairs of electrons, again, the easiest way to kind of arrange this, I think, is to put the iodines here and then rub out all of those and make those lone pairs there. So a lone pair here, lone pair there, and a lone pair here. The lone pairs are all pushing each other within that plane, but not above or below. So the bond angle here will still only be 180 degrees, and that will be linear. So let's draw that into here. So there's iodine. And then I've got a lone pair of electrons there, another one there, another one here, and that's 1 minus, with a bond angle of 180 degrees. So the final section here is looking at what we've got in the bonds here, okay? So, and you can't take it as read as what it looks like on the page. So we're looking at this bond angle here, the hydrogen, and the carbon. So you've got to basically go back to it. I mean, you'll get to familiarise yourself with these anyway. The carbon's going to be tetrahedral, which means it's going to be a bond angle of 109.5. But if you couldn't, carbon has 4 electrons in its outer shell because it's in group 4. Hydrogen forms 1 bond, okay? And you've got 3 of those. You've got a carbon that is forming 1 bond as well. So that's going to give you a total of 8 electrons. Divide by 2, that gives you 4 pairs. They're all bonding, which means it's going to be a tetrahedral with a bond angle of 109.5. But you really need to know that around a carbon, it's going to be tetrahedral. These are one of the 5 parent shapes that you have to know. Okay? With the next one here, so we're looking at this bond angle here, okay? And again, around the carbon, remember carbon can only form 4 bonds, but the 4 bonds that are around there are in 3 repelling areas. So out of the 4 bonds, okay, so let me do that slightly differently. So we've got 2 single bonds and 1 double bond, which gives you a total of 3, which is going to be trigonal planar. Trigonal planar, that's that shape there, has a bond angle of 120 degrees. Yes, the angle will be slightly smaller because it's a double bond, but it would be fairly negligible, so just 120 degrees here would be fine for that one. And then the final part in this one is looking at the COH bond angle, which is this bond angle here, so that bond angle there. And you really do have to kind of go back to what we've been doing with this. So oxygen is in group 6, it has 6 electrons in its outer shell. Hydrogen is forming 1 covalent bond, carbon is forming 1 covalent bond. That is a total of 8 electrons. Divided by 2, that gives you 4 pairs. But of the 4 pairs, if you look at the diagram, out of the 4 pairs, only 2 of them are bonding pairs, which means the other 2 must be lone pairs. So 2 bonding pairs, 2 lone pairs. So that's going to be based upon tetrahedral. But 2 of them, remember, are going to be lone pairs. So let's remove those, put the lone pairs on. So that's going to be non-linear with a bond angle of 104.5 degrees.